Let us look at cubic equations, part 2. And here we are going to find roots of the cubic equation. Let's take the first example. We have x cube plus x square minus 16x plus 20 is equal to 0. First, try to guess one of the roots. Often small integers like 0, plus or minus 1, plus or minus 2, plus or minus 3 will usually work. Of course, if it doesn't work, then we'll have to think of something else. So x is not equal to 0, since 0 plus 0 minus 0 plus 20. Now, let's say x equal to 1. So we have 1 cube 1 plus 1 minus 16 plus 20. So again, not equal to 0. Now, x is equal to 2 works, since 2 cube is 8 plus 4 is 12. 12 minus 32 is minus 20. Plus 20 is 0. So which implies that x minus 2 is one of the factors of the cubic equation. Now, once we know one of the factors, the cubic reduces to a quadratic. So here, one of the x's has come out because this is a factor. So the other factor will have x square. The other one will be a quadratic equation, which we already know how to solve. So to get the quadratic, we divide the cubic by x minus 2 using log division. Because here we have not yet found the quadratic. We will have x minus 2 times some quadratic expression equal to 0. So to get that quadratic, we take x cube plus x square minus 16x plus 20 and divide it by x minus 2. So here we have done that division. And by carrying out the long division, we arrive at x square plus 3x minus 10 as the other factor. That is x square plus 3x minus 10. Now we need to factorize this again. Again, we know how to do factorization of a quadratic. So x square plus 3x minus 10 is equal to x plus 5 times x minus 2. So our cubic equation becomes x minus 2 times x minus 2 times x plus 5. X minus 2 we had already found, and x minus 2 times x plus 5 is the factorization result of the quadratic. So the roots are 2, 2, minus 5. Because each one of them will be equating it to 0. So these numbers will go to the other side, in which case the signs will reverse. Now let's look at the graph of this. So graph is this. And let's look at the roots. That is the curve intersecting the x-axis. We have 2 and we have minus 5. And 2 will be repeated. Now the second problem. X cube minus 4x square plus x plus 6 equal to 0. So again, trying small integer values of x, we get x minus 2 as one of the factors. Divide the cubic by x minus 2. We get x square minus 2x minus 3 is the other factor. This is a quadratic. We factorize this to get the other factors. So x minus 3 and x plus 1 are the other two factors, and therefore the roots of the cubic are minus 1 plus 3 and 2. And this is the graph of x cube minus 4x square plus x plus 6. And the roots are minus 1, 2, and 3. And all are real. Now let's look at the third one. X cube plus x square minus 9x minus 9 is equal to 0. Now we are going to use a slightly different technique. We group these two, x cube plus x square, and we group these two. So minus, we take it out common. So minus, and within brackets we have 9x plus 9 is equal to 0. Now x square is common. We take it out, x square times x plus 1 minus 9 is common. So 9 times x plus 1 is equal to 0. Now x plus 1 is common to both of them. So we take it out. So we have x plus 1 times x square minus 9 is equal to 0. So x plus 1 is equal to 0 and x square minus 9 equal to 0. And x is equal to minus 1 is one of the roots. Now what about x square minus 9 equal to 0? We need to recognize that this can be written as x square minus 3 square equal to 0, which is nothing but a square minus b square. And we know it is equal to a plus b times a minus b. So we have x minus 3 times x plus 3 equal to 0, which means x minus 3 equal to 0 and x plus 3 equal to 0. So x equal to 3 and x equal to minus 3 are the roots. So the roots of the cubic are minus 3, minus 1 and 3. All are real and distinct. Again, let's draw the graph of this and let's look at the roots. We have minus 3, we have minus 1 and we have 3. Now we have x cube minus 8 equal to 0. So x cube equal to 8 and x is equal to cube root of 8, which is equal to 2. So one of the roots is 2. Remember, this is a cubic. So which means there will be 3 roots. We have found only 1. But doesn't seem like we would be able to find the other 2 roots. Okay, let's see. X cube minus 8 can be written as x cube minus 2 cube equal to 0. Now we know a cube minus b cube. What is it? So we know a cube minus b cube is equal to a minus b times a square plus ab plus b square. Here a is equal to x and b is equal to 2. So x cube minus 8 is equal to x minus 2 times x square plus 2x plus 4 equal to 0. Now we solve x square plus 2x plus 4 equal to 0. We use the quadratic formula. So x is equal to minus 2 plus or minus square root of 4ac. So a is 1, c is 4. So 16 divided by 2 times 1, that is 2, which is equal to minus 2 plus or minus square root of minus 12 divided by 2. X is equal to minus 2 plus or minus, remember square root of minus 1 is denoted by I. So I times, so which means square root of 12 is 4 times 3. So 2 can come out. So 2 root 3 divided by 2. Now 2 can be factored out from the numerator and it gets cancelled with the denominator. So we have minus 1 plus or minus I root 3 by 1 and we separate out the 2 roots. X is equal to minus 1 plus I root 3 and x equal to minus 1 minus I root 3. So we have found the 3 roots, minus 1 plus I root 3, minus 1 minus I root 3 and 2. One is real and the other 2 are complex conjugates. So if we graph this, what do you expect? Remember, the complex numbers can't be plotted in the xy plane. So we would expect only one intersection. That is 2. That was finding the roots of the cubic equations. We can also say solving the cubic equation. That's it for now.